Our goal is to graph this sinusoidal function and list some of its attributes here. So starting at the top, amplitude. Amplitude is determined by the number that's multiplied out front. Amplitude is a distance, the distance from the center to the top, the center to the bottom. So it doesn't make sense to talk about a negative distance. The amplitude is 2. That negative sign is going to cause, when we do the graph, it's going to make a reflection across the x-axis. So we'll make sure to put that in when we do the graph, but it doesn't affect the amplitude. The amplitude is 2. Next, the period. Period is 2 pi divided by whatever's multiplied by the x, which is a 2. So the period for this particular sinusoid is pi. So it's going to be compressed by a factor of 2 from the original version of the sine function. Phase shift would be if I had something added in here with the x, which I don't, so I don't have a phase shift. It's not moving left or right. Vertical shift, I do have that. The whole thing is moving. That's positive 3, up 3. So VS for vertical shift, up 3. We do want to say an actual direction there. Domain. Well, every sinusoid, the domain is all real numbers. Range. Okay. We're going to think through this here. The range of the generic sinusoidal function is -1 to 1. But the amplitude of this one is 2, which is going to increase the range. It's going to move the ends apart from each other. And then I have this vertical shift, which is going to affect the range, the y values, up 3. Well, that means the bottom is going to move up 3, -2 plus 3, and the top is going to move up 3. The center, the midline of the graph is going to be halfway in between. There's going to be at 3. And I'm going to go up 2 and down 2 from that center. Okay, so we got all the stuff in the list. Let's draw a graph. Let's see. Period is pi. So I'm going to label my x-axis first. Period is pi. That means halfway through is pi over 2. Halfway between there is pi over 4. We want to split the period, the length of the period, into our 4 equal pieces here. And halfway between 1/2 and 1 is 3/4. If you're ever not sure, you can find the midpoint by adding together the two ends and divide by 2. So if you weren't sure what's halfway in between here, I can just add together pi plus pi over 2 and divide by 2. So it's really just literally finding the midpoint the same way you've done for a long time. So my x-axis is ready to go. It's labeled. The y-axis, well, let's see. My range goes from 1 to 5. Like that. I like to put a little dotted line here in the middle. You don't have to. It's just a little easier to tell what's going on if you have that as a guide. And here we go. This is a sine function, so I'm going to start in the middle. Ordinarily, at my first tick mark here, I'd be at a maximum except for this negative here. So I get a reflection. I'm going to go to the minimum and then back to the center, up to the top, and there's the end of the period in the middle. Connect dots, make sure it looks like a sine function. Sine functions are nice and wavy and not at all pointy. And there's my graph. Hi, Kat.